Here is your fast finishes worksheet. Just notice that it has a little introduction telling you that these are test practice questions. So you will have questions in the test over here where there's filling in the blanks, and this one is about proving that a particular equation equals 1. There's 2 changes, please. Could you change this u to the 5 to u to the 6? That one's no big deal. If you left it as 5, it's just that you would have a negative power sitting in your answer, and negative powers do exist. In class we've talked about index law number 5 and that it is negative powers, but we just don't really do it in grade 8. Down here though, this does need to be changed to a 6, otherwise we're not going to get to what the question's asking. So the z here needs to be changed to z to the 6. So this question, you can see there's bases of p's and bases of s's. So if you add P9 and P14, sorry 4, you get P13. So keeping the base of P and adding those powers. And then you have S to the 12 left on the top. Okay, we're going to keep our base down here of P. So we've got P4 and we know that's P1. So that has to be P5. Sorry, the focus isn't as good today, is it? And S3 and S8. So we're going to keep the base and add the powers. So our 3 and our 8 will get us to 11. Okay, now we're looking at index law 2, when we have to keep the base of P and subtract the powers. So 13 take away 5 is 8, and S12 take away S11 is S or S1. This one here, you can see that we have multiplying and dividing again, but we have this idea of 22 divided by 88. Now we know that's not possible to divide 22 by 88. There we go. So now we need to simplify another way, and I look at both of these numbers and I see they can be divided by 11. So 22 divided by 11 is going to simplify it down to 2. And 88 divided by 11 is going to go 8. Now if you look at that, it can actually go down smaller again. They can both be divided by 2. Okay, so this is going to end up as 1 over 4. We need to work out our bases and powers. So let's just focus on the top here. We've got U6 and U3. So that's going to get us to U9. And V9 and V2 is going to get us to V11. Down the bottom, U3 and U6 is U9. V2 and a V is V3. Okay, so we've done lots of simplifying. We've simplified our pronumerals, okay, and then we've simplified them again, and now we've collected our like terms. So we've simplified it to less bases and powers. So what we need to do to finish off is we're going to have to leave the 1 and the 4, but now we're going to go, well, U9 take away U9 is 1, isn't it? That's an interesting one actually, because if you think about U9 divided by U9, well, our rule is to keep the base and subtract those powers, so we're going to get U to the 0. Okay, so U to the 9 by itself, which is part of our equation up here. If we think about it, it's keep the base, subtract the powers, which gets us to U to the 0, and actually gets us to 1. Okay, equals 1. So some people would cross that out. It's fine to cancel out. Okay, some people would cross that out and think that it actually equals 0. It doesn't, it equals 1. But 1 in our equation here isn't going to make any difference. Okay, so you can ignore it because 1 times 1, you know, our u's have turned into this value of 1 here. It's not going to change anything at the top. Then we've got V11, take V3 as V8. So we've got this 1 times 1 again, which we know this 1 came from really thinking about our rule of keep the base, subtract the powers. We end up with u to the 0, which equals 1. But 1 times 1 is just going to be 1, and V8 divided by 4. So this here is your answer. This was just an interesting revision point. Okay, to keep the base, subtract the powers. You can just cancel those out. You don't have to do the extra. You can just cancel out and ignore, but it's not cancel out and ignore because it equals 0. It's cancel out and ignore because it just equals 1 anyway. Right, this little question here is, well, you've got to keep the base and multiply the powers. Okay, in the brackets, multiplied by, alright, so b to the 0. Well, okay, so keep the base, multiply the powers. So you can keep b. What's 0 times 4? It's still going to be 0. Okay, 0 times 4 is still going to be 0. And then we've got c to the 4 power. So you could ignore this because it just equals 1. So you're left with a 12 c 4. I think we'll do this question and then I'll make another video for this one, because if they get to about 10 minutes they take a long time to upload. Right, so simplify to prove that it equals 0. Okay, now I guess we w to the negative 4, w to the negative 4. Again, you can just cancel those out. I know they're negatives. Even if you think about them as positives, it's going to be the same. Okay, so if you thought about it as w4, because you don't like the negative, over w4, it's going to be the same. That w, it's going to be 4, take away 4 if you're thinking about it, because keep the base, subtract the powers, and it's going to get to that, because 4 take away 4, and anything to the 0 power is 1. It would work out the same with a negative. Okay, going back to term 1, you could think about how you work your negatives, but there's no need. You can just see that they would cancel out and equal 1. Okay, here we've got, so we need to make some working here. So we're going to ignore our w's, and now we've got keep the base, multiply the powers, because it's index law 3 there, so it's going to be x to the 12. Okay, y to the 0, well, you can see that that cancels out top and bottom as well, and then you have z to the 8th power. Okay, down the bottom you've got z to the 6 and z to that 2 here, so you're going to keep the base and add the powers for this section here, the z's, and then you have left your x to the 12 down the bottom that was given to you. So now you can see that it's all going to equal 1. Alright, if you think about the x's, they cancel out, but it's not equaling 0. Okay, even the question tells you it has to equal 1. So we'll just do some thinking again over here. If you're looking at your x's in isolation, okay, it's going to be x12 divided by x12. And if you think about that, that's an example of keep the base and subtract the powers. And you end up with x to the 0, which equals 1. Everything's going to equal 1. So this could be 1 multiplied by 1, because we're going to go, well, z to the 8 and z to the 8. If you look at that in isolation, it looks like this. When you have space, z8, take away 8, keep the base, subtract the powers, equals z to the 0, which equals 1. Okay, so that's, I guess, showing you that when you cross things out because they're sitting on the top and the bottom, you're not crossing them out because they equal 0, you're crossing them out because they equal 1. Okay, this question here, this works out to be keep the base, multiply the powers, so that's going to be r to the 12th multiplied by r to the 3 over r to the 15. Okay, then you can see this is r to the 15 divided by r to the 15, because you're going to keep the base of the powers there to get your 15 here. Keep the base of r, add those powers. And again, you can see this is another example of they cancel out, not because they equal 0, but keep the base, subtract the powers, would end up to be r to the 0, which equals 1.